Assalamu alaikum. My name is Meshal Alaqil, and this is my colleague Ali Hassoun. And today we're going to present our senior project video.
Thank you, Meshal. Today I will present to you our senior project, Mega Plant Production System Optimization and Demand Forecasting. First, let's talk about Minabev. Minabev is one of PepsiCo butterers that operate in the west coast of Saudi Arabia. They are responsible to produce all PepsiCo product and sell it in the western region. The PepsiCo products came in different packaging such as PET, glass and can, and the canned beverage takes the high proportion of sales and production. Therefore, the factory allocates high proportion of its budget on canned beverage production. Large percentage of that budget is spent on empty can associated processes. Therefore, we'll be optimizing some of these processes to have economical operations. Our objective is to decrease the cost of excess empty cans with accurate forecasting, decrease the operation costs related to empty cans, also optimizing high cost process such as empty cans delivery schedule. Finally, we will decrease the cost of ordering and holding empty cans by decreasing the buffer needed in ordering. First, optimizing empty cans delivery schedule. We'll optimize this process using integral program model that take the production plan of the mega plant for the week and the stock level of empty cans in the plant and the supplier. Also, we'll check the production capacity of the supplier to satisfy the mega plant demand. Then, it schedules the deliveries between the supplier and the plant based on the previous elements.
Thank you, Ali. Accounting for production scrap rates and raw material ordering. So, when they order raw materials, they also have to add more quantity to account for scrap rates, which they determined in the factory to be 5% of scrap rate. So, we are going to determine a lesser percentage of scrap rate through using the upper-tailed t-test. When we use the upper tail, we get the worst possible outcome of defective parts, which we call the worst case scenario mean. So, as a population mean, through the upper tail t-test, we have 5,779 units of defective parts. We use the lower tail t-test to get the population mean of the production quantity, which is 12,021. So, you have lower production quantity and higher defective parts. So, when you divide both of these together, you get a percentage of 2.726%. So it's a buffering. We account for scrap rates when we order excess material, which we order more 2.726%. Agile inspection production system. Agile strategy, it's like the constant workforce, but instead of having a maximum of 110 workforce, no. You take the minimum, 97 workforce, and whatever months that needs more workers, then we will have to rent them using Agile. It's a substitute to the hiring and firing approach. You just rent him for like 1, 2, 3 months period. It's a short-term contract. Depends on your needs. So when we compare the Agile strategy, Agile saves money more than the constant workforce by 113,500 reals. Here we use the critical cost ratio because we do not have a clear pattern of the data, or it's not applicable for the whole points of data. So after we made the normality test using Minitab program, we figured out that the normality is applicable by a p-value of 0.37, which we accept the null hypothesis, so we applied the normality. And here we've got, after the calculations, an optimal quantity of 591,403. Here we've used Halt's method and linear regression method to forecast the demand. We forecasted for the same year and steps ahead for the next year. Why? For both of these, the same year and forecasted steps ahead for the next year. Because we want to measure the errors of both of the Halt's and linear regression. After measuring the errors using the MAD, MSC, and MAPE, we figured out that Halt's has a better estimate of the forecast. Halt's is a more accurate method. Findings: the delivery model, buffer ordering reduction from 5% to 2.75%, 113,500 real through Agile strategy cost reduction, 250 millicans critical cost ratio, which is a 78% certainty. Halts and linear regression cans forecasting. These methods are quite findings and suitable for production systems and factories. Thank you for listening.